Once our ecosystem was constructed, our two fish were thriving in our 20.3 degrees Celsius water. This temperature affected the DO concentrations in the aquatic chamber, which started at 1.7 milligrams per liter. Since the DO concentrations were in the range of 2 to zero point 0.5 milligrams per liter, it was considered hypoxic. The pH started off relatively neutral at 6.7, which is normal considering streams usually have a pH value ranging between 6 and 9. Since the water in the aquatic chamber was not too acidic or basic, the hydrogen or hydroxide ions did not distribute to the fish. For the terrestrial chamber, the temperature was approximately 20 degrees Celsius and the pH was neutral at 7. On day 2, the temperature slightly decreased in the aquatic chamber, but did not decrease the dissolved oxygen. However, we experienced an experimental error when measuring the dissolved oxygen, and it increased greatly to 5 milligrams per liter, being much higher than any other data we collected. The salinity decreased from 100 to 90 parts per million, and therefore our gas solubility increased. The pH slightly decreased to 6.1, which means the concentrations of metal increased because the acidity increased. So did the ability to be dissolved from sediments into the water. In the terrestrial chamber, the temperature decreased from 20.2 to 19.6. The pH barely decreased from 7 to 6.9.
On day 3, the aquatic chamber temperature went up by 0.1, making it 19.1 degrees Celsius. This slight fluctuation shows that the metabolic activities did not speed up, slow down, malfunction, or come to a complete halt. The pH went back up to 6.67, proving that smaller amounts of ammonia were needed to keep the water sustainable to aquatic life. The salinity decreased from 90 to 60 parts per million, which proved the gas solubility increased again. For the terrestrial chamber, the temperature went back up to 19.8 degrees Celsius, and the pH also increased back up to 7. On day 4, the aquatic chamber's temperature increased again to 21 degrees Celsius, and the pH went down to 6.35. The salinity also went down from 60 to 40 parts per million, and the DO was at 2.2 milligrams per liter. The terrestrial chamber started forming condensation on the walls, and the temperature rose to 21.1 degrees Celsius, the highest we had seen yet. We hypothesized that our ecocolumn was developing similar characteristics to the rainforest biome because the moisture collecting in the chamber was creating a more humid environment. The pH remained the same at 7 because our ecocolumn was thriving and all our critters were creating a stable environment.
On day 5, the aquatic chamber remained the same at 21 degrees Celsius. The pH was also the same at 6.3, just below neutral. Our salinity had risen by 20 parts per million, making its way to 60 parts per million, the same as day 3. Our DO had risen to 3.7 milligrams per liter. Since the DO is above 3, it did not put stress on our aquatic organisms, but our water was slightly murky. Our terrestrial temperature reached its highest out of our data collected to 21.9 degrees Celsius. However, the soil pH remained neutral at 7. On day 6, our aquatic chamber temperature slightly decreased to 20.1 degrees Celsius. The pH remained consistent at 6.33, while our salinity went back down to 40 parts per million. The dissolved oxygen fell below 3 to 2.7, which put more stress on our aquatic life. The temperature in the terrestrial chamber fell to 20.7. Because the temperature decreased in the terrestrial chamber, it affected the DO in the aquatic chamber. The soil pH meter read once again a neutral 7, and our worms were helping sustain the flora in the ecocolumn.
On day 7, our aquatic temperature was at a stable 20 degrees Celsius, while the pH had fallen to 6.06. The salinity had risen back up to 20 parts per million, showing a slight fluctuation over the past week. The DA concentration rose back up to 3.2. Since our DO was never hypoxic, it did not fall below 20 milligrams per liter, so our fish was able to stay alive the entire time. The terrestrial chamber stayed the exact same temperature at 20.7 and the same pH again at 7. The nitrate concentration for our aquatic chamber was 0, which meant our ecocolumn represented an oleotrophic freshwater system, so there was a low level of nutrients. The turbidity for both day 2 and day 8 remained at 0, which meant our water was pretty clear. Low levels of turbidity indicated a healthy, well-functioning ecosystem with moderate amounts of plankton present to fuel food chain. Since there wasn't high turbidity, our plants got enough sunlight for aquatic vegetation to survive. An increase in nitrate from 0 to 1 also increased our phosphate from 0 to 0.2. Because the phosphate increased, it encouraged our aquatic plants to grow. In the terrestrial chamber, the potassium for day 2 was 150 pounds per acre, and on day 8 it had risen to 200 pounds per acre. This increase helped the wheatgrass mature and develop strong enough roots for it to reach the top of our ecocolumn. However, the potassium contents decreased. On day 2, it decreased from 200 pounds per acre to 160 pounds per acre. The amount of potassium in the plant decreases as it matures, therefore explaining why the potassium decreases and our plant growth increases. The nitrogen concentration stayed the same at 20 pounds per acre for both days 2 and 8. Nitrogen barely fluctuates over a period of years, let alone 3 weeks that we did this project, thus remaining at a constant level.